Hello, and this is Mr. Stewart. Welcome to the final quiz of Chapter 7. It's titled the 7.6 Homework Quiz, Area of Triangles and Quadrilaterals. So this is, strictly speaking, completely a review. To find the area of triangles, parallelograms, trapezoids, rectangles, and squares is all stuff that was considered the 6th grade core and was, I know for a fact, taught to at least the 6th graders at our school last year. But like most things, if you don't use it too often, you lose it, and so a lot of you are going to look at this as if this were brand new. So we give the little quiz to just kind of review. We don't spend a lot of time on it in class, but we do still give it, and hopefully this is going to be helpful for you. And so let's just get right into it. Okay, so if you're looking at this shape, you'll recognize it as a parallelogram. A parallelogram is a quadrilateral that has two pairs of parallel sides. Okay, those are parallel. And, well, let's just talk about parallelograms for just a moment. We did this activity in class. It's part of your Chapter 7 Computer Discoveries folder, so you're welcome to go explore this again. If you look at parallelograms, what you're noticing here, this is a parallelogram, and it's got a base of 5, meaning from point A all the way to the corner here. Okay, and then it's also got a height of 5 from point H all the way up to point F. Okay, so and I can increase or decrease the size or whatever, but let's just keep it here for just a second, maybe. Okay, so what you're noticing here, this app tells you what the area of this parallelogram is. It's 25. And how do you get that? Well, the short answer is it's 5 times 5, base times height. And you might think to yourself, well, that works for squares and rectangles, but parallelograms, surely there must be something special with parallelograms. And the answer is simply no. No, there's not. Take a parallelogram, any parallelogram, and cut off the corner of one of the side lengths from here to here. Cut it off and slide it over. What you have now is a rectangle. In this case, this is a square, but always a rectangle, where you have the same base of 5 and the same height of 5. Now the question is, from the area here to the area here, did the area change at all? Did the amount of shape change? And the answer is no, it did not. That means the area is the same, which means that to find the area of a parallelogram, you just take the base and multiply it by the height, and you're done. So when you look at this, you got to recognize, and I'll just help you recognize this right now. The height is the distance from here to here. The base is the distance from here to here. Now, you can think about it and say, well, that's not the base, Mr. Stewart. The base is this, and that's the same thing, 13, and the height is still 1.5 feet. So this I put in here just to throw you off. This is not necessary. This side length here is 3 feet, but it does not help us find the area of this trapezoid, the amount of space within this trapezoid. So once you find that, just put the number. I've already labeled it as feet squared, so don't worry about that. Just put the actual number there, and that should be it. Okay, question number 2 is a trapezoid, and so you're welcome to look up the formula for the area of a trapezoid. I don't expect you to memorize it, but there is a point where I think if you understand how we come up with these, then there's no need to memorize it. You can just sort of figure it out. And let me go back to this example here. I'm going to click now on trapezoids. Okay, and trapezoids can look different depending on how you do it. It doesn't really matter. Okay, a trapezoid is just a shape that has one pair of parallel sides, and it could have at least one pair, so it could have 2 pairs of parallel sides. But here's a trapezoid, and I want you to make note there's a base that's in red called base 1. Okay. There's a base in green called base 2, and then there's a height, the H. Okay, and here's your hint. Okay, what I did here is I literally replicated the trapezoid, copied and pasted it. And I'll do it one more time. Copied and pasted it and slid it over and flipped it. And now what I'm hoping you're understanding, or what you're discovering here, is that this new shape is a parallelogram. Well, we just talked about parallelograms. We just talked about how to find the area of a parallelogram. So if you think about it, the entire area, all of this space in here, all of this space, okay, can be shown as base times height. Okay. Only this parallelogram, the distance between here and here is going to be base 1, right? Base 1 plus this base distance of base 2. So if you think about it, whenever you're working with a trapezoid, you're going to be working with two different lengths of bases, from here to here and from here to here. Okay. So the formula that we talk about starts with us adding the two bases together, base 1 plus base 2. That's where the formula starts. So we're not done yet, but that's what we always do first. We take the trapezoid, okay? Now, what's happening after this, what I'd like to do is you got to think, okay, if I'm going to find the area of this trapezoid, of this parallelogram, I keep messing up. I'm going to find the area of this parallelogram. I'm going to take the base, which I decided was B1 plus B2, and then I'm going to multiply it by the height, because that's how you find the area of a parallelogram. It's base times height, which is great. I've just found the area of this parallelogram. Now you need to think to yourself, okay, I found the area of a parallelogram, but this parallelogram is not the same area as the trapezoid that I was originally trying to find. The area of this trapezoid is exactly half of the area of this parallelogram, right? I took the exact trapezoid, copied and pasted it, so I've effectively doubled the trapezoid. So what I want to do then is take away this half. And how do I mathematically cut something in half? Well, that is just dividing the whole thing by 2. So this formula that we just came up with, base 1 plus base 2 multiplied by height divided by 2, is the formula for the area of a trapezoid. And so, a lot of students just want to memorize it, use it for the quiz, and then forget it. But this visual helps us understand a lot. Now, there's other ways that you might write this formula, so I'll just also help you out with this. You may see it as base 1 plus base 2 multiplied by 1/2 and then multiplied by the height. You may also see it like that, and that works as well. In fact, my favorite way to do this would be, and maybe I'll just wipe this clean for just a second. Here's your trapezoid. Let's just make one up, okay? Let's say the height was 5, and oops, you can't see that. Let's say the height was 5, and let's say the base was 5, and let's say the other base was 11, let's say. I don't know, okay? So the way I do this is I take the two bases and I add them up. So 5 plus 11, and that equals 16. Okay. So I've got my base times height, and what I like to do, because it's base 1 plus base 2 multiplied by half multiplied by the height. Well, I've got this part right here. That's 16 is base 1 times base 2, and it really doesn't matter if I multiply it by the height first or by the 1/2 first. So it's easier to cut things in half first. So 16 cut in half is 8. Okay, so I just took 16 and cut that in half, and that equals 8. Okay, now I just need to multiply it by the height. So I need to now take 8 and multiply it by the height, and the height is 5. So there you go. 8 times 5 is 40, so I would say the area of my trapezoid is 40 units squared, whatever those units happen to be. Okay. Now let's go back to the quiz question, and you've got a trapezoid. The first base, this is going to be equal to base 1. Base 1. The second base is equal to this is base 2, or vice versa. It doesn't really matter. And the height is represented by 18. This is equal to the height. 20. again, here's a hint, don't need it. It's just there to throw people off. So just think of 18 as the height, or yeah, not 20. And use the formula that we just talked about, and you should be able to find the area in feet squared. Okay, question number 3. So there's a few things you need to understand about question number 3. And the first one is, this is a triangle. And let's go to our activity for just a second and talk about triangles. So how to find the area of a triangle. Any triangle that you have is going to be exactly half of a parallelogram. So you can take a triangle, like the one we have here, and copy it and rotate it and paste it and move it, and what you've done is you've effectively created a rectangle. Now we already know how to find the area of a rectangle. Okay, to find the area of a rectangle, it is base times height. Or I'm sorry, I did that backwards. Base times height. Base times height. That's easy. And what happens is I've just found the area of everything here. I found all the amount of squares that fit in this area. But of course, what I've just done is found the area that is twice as big as the actual triangle. So we cut it in half. This is why we say that the area of a triangle is equal to 1/2 base times height, because every triangle can be, or is exactly 1/2 of a parallelogram, and it's easy to find the area of a parallelogram. We just take the height and the base and multiply them together. So that's what we're working with here. Now you can make it into any kind of triangle you want. So an obtuse triangle, let's do it like that, is going to be its base of 5 down here, base of 5 multiplied by the height. Now the height, this is interesting, the height is the straight vertical up and down distance as if it were resting on the ground. Okay, so the height is from this point to this point, which is 7. So you do base times height and then divide that by 2. Let me show you what I mean by that. So base times height would give you this amount. Then you divide it by 2 to get you this amount. You can do, an equilateral, no, I'm sorry, an isosceles, or an acute triangle of some kind. And, no matter where I move this, it stays the same there. But so you get yourself a triangle with base of 5 and 4, and a height of 4, and that'd be 5 times 4 is 20, divided by 2 is 10. You can clearly see, that's not going to show me the rectangle at this point, but it would be half of that rectangle. So going back to this, the thing that students get stuck on is, well, Mr. Stewart, I don't have either. You didn't give me the base. I don't know what that is. You didn't give me the height. I don't know what that is. I know this is 4, and that's great, but that distance, 4, from here to here, is not the same as the height. The height is going to be smaller than 4. So I don't know how to find the area of this triangle, Mr. Stewart. I'm stuck. So I gave you a hint. Try looking at the triangle from different angles. To show you what I mean by that, I'm going to take this right here, same triangle, and I'm going to begin rotating it. Okay. Anytime we can get the base to be resting on a ground, that's kind of what we're going to be doing here. What you have here now is a triangle that hasn't changed in size at all. Okay. But its base from here to here is what? 4. What is its height? Well, from here to here, it is 4. Now you have a triangle with a base of 4 and a height of 4. How do you find the area of a triangle? I'll let you figure it out from there. The last question asks you to find which of these 5 different shapes have the largest area, the greatest area. So just a single answer. So you know how to find the area of a square, base times height. You know how to find the area of a rectangle, base times height. You know how to find the area of a parallelogram, base times height. You know how to find the area of a triangle, base times height, divided by 2. And you know how to find the area of a trapezoid, base 1 plus base 2 multiplied by height, then divided by 2. To Tell me which one has the greatest area, and mark it, and you should be done with this quiz. I hope this is helpful for you. If you have any further questions, please come talk to me or one of the other math teachers, and have a great day.